Hi guys, Sten here. I just wanted to show you the model that I created for predicting football results. I've written about it on the blog, but some things are just easier to show than to tell you about in writing. So just a quick presentation. I'll try to do this in a few minutes and not give you too much detail. But anyways, I've looked at all of the different prediction models, and most of them are based on either ball possession or the difference of the goals in the team, or some of the better models are done on expected goals. And those of you who don't know what expected goals are, you can look it up at the blog, where there's a lot of information on it. But I found them to be limited, so I decided to try and build something new, something else. And the idea for this model came from Soccernomics. I love the book, and there was a very strong correlation between the player's salary relative to other teams and the club's position at the end of the season. So I thought, well, this kind of makes sense because better players, they win more matches. And player salaries are kind of supply and demand driven. Yeah, they're not ideal at predicting results on the football field or the effectiveness of the player on the football field, but it's a pretty accurate indicator of how good the player is. And the hypothesis for this model is that more expensive teams, they win more matches. So this is what I've decided to do. I decided to look at player salaries and go back as many seasons as I can. So I looked at about 4,200 matches of Italian Serie A, just to get enough data points. And that was for the seasons of 2006 up to 2017, so 11 years based of data. I got all of the results, as well as I wanted to find out what the player's salary were. And for that, there was Gazette dello Sport that officially publishes player salaries. I don't know how official or accurate this information is, but I had to use this data point. And this is an example of the data input that I would use. The model is driven by one thing only. It's driven by the relative wage bill. So if Team X outspends Team Y, I wanted to know how often or how probable is their win at home, is there a draw at home, and the away win. And this is the outcome. It's fairly straightforward to look at this. If the teams are evenly matched, you can expect that 49% of the time the home team will win, 27% of the time there will be a draw, and 24% of the time the away team will win. So one means that they are fairly evenly matched, so the value of the home team divided by the away team is around 1. Now, as we move away from this, you can see that, like, if a team A is 4 times more expensive than team B, well, now their probability is much, much higher. And likewise, if the home team is much less expensive than the away team, they only win an average of 15% of the time. Just wanted to give you a very quick overview of the model itself. It's in Excel, a lot of data points. It took me about 3 or 4 months of putting this together, but here it is. You're welcome to take a peek. This is how it works. You have all this statistical information looking up the values of the teams and then comparing those, transferring those values into a ratio. And this ratio drives the results. So let's take an example of Manchester United and Leicester City. This is going to be the first game of 2018-2019 season, right? How would I estimate the probabilities? Well, what I would do is that I would enter the value of Manchester City wage. In this case, last year it was 220 million pounds. Leicester City had a wage bill of about 66, sorry. So we arrive at probabilities now. We have a probability of Manchester winning about 65%, probability of a draw about 21%, and the weight probability of only 14%. How did the model arrive at this number? So this divided by that, this is the value that was looked up, and the system took results of 200 matches that had similar ratio in wage. What I've done after that, I've looked at some of the historical results, and I said, listen, what if I use this example and try to find value bets on betting markets? Is that going to work? Am I going to be profitable? Because what I found is that the betting markets are not always showing results probability similar to mine. So I went back, and of course I tested different leagues just to make sure that I'm not using the same league. And this is data from La Liga 2017-2018. And I looked at value. So if I had a value bet, and if you don't know what value bets are, feel free to look it up on the blog. I looked for the value bet of 15% or more. And then I told the spreadsheet, every time there is 15% or more value bet, put an amount in, and make sure that this amount is. I wanted the average bet to be about $20. That's how I functioned it. So I started off with about $500 in the beginning, and every time there was a value of $15, I put a bet in. And at the end of the season, we had $994. And a similar test on the English Premier League was quite positive as well. I'll quickly give it to you. This is 2016-2017 season. Again, started off $500 bank. That's the assumption. I made the bet to be an average of flat $20 and run the simulation. At the end of the season, I was at $1,322. So I think this model has a bit of potential. Obviously, it's not something I'm going to use to go and bet away all my life savings, but there is room for improvement and there is room for development. Those are the results of the test. Now, be careful, because this very simplistic model doesn't have any data on injured players. It doesn't account for somebody's performing very poorly, but they have a 3-year or 4-year contract, and it looks at the overall team, not the individual player salaries. So with transfers, that can change very fast. But I'd love to hear some of your feedback. If you have ideas how to make it better, if you have ideas what to look at, maybe how to optimize my betting strategy, I'd be all ears. Just drop me a note. I'm going to include a link to my blog if you want to get into it with more details. And yeah, thanks for watching.